Hello guys and welcome back. Now it's been about 3 months, my longest break from YouTube as it is. I haven't stopped making videos, it's just that I made small build prototype videos on my Patreon channel for the time being. Today we're going to look at this parcel. Now unfortunately Jonathon sent me this back in January I believe, and it's sat in the storeroom next door until now. I couldn't do anything for the last few months while I tried to get the single seat behind me sorted. More videos on that later. Right now, let's open and see what we've got. Now, I do believe this is a 737 throttle. And I really didn't want to take any more 737 throttles on. So please don't send me any more. I want to kind of expand out and do other things. But I have no idea who made this or what's actually in here. I'm probably opening this box all completely wrong. I am, yes. Oh well. There we go, it's open. Right, packing fluff. Oh wow, okay. Well, that's not a good start. That's definitely a 737 throttle handle. They're the thrust reversers, the thrust reverser levers in fact. Okay, so what have we got? Well, first thing I noticed is it's not sitting down straight. Oh, wow. Okay, so the reason it's not sitting down straight is that we've got the Arduino right at the bottom. We've got this ground cable here, I'm going to guess, that is stuck to the bottom as well, and that's preventing it from sitting down. So the next big thing I've noticed is this throttle lever plate has snapped off the handle. That should be an easy fix. What would be really cool is we could 3D print these, which means then if these break again, Jonathon can just reprint them at home. That's going to go on there. Okay, so I'm just having a quick look around to see what else we've got. Now it is actually quite a tidy little unit. Someone's done a really good job. So the fuel cut-off levers are very soft, but they work perfectly. No issues there. Let's turn it over and have a look. Now it does look like it might even have backlighting, and they've done a really good job with the backlighting, the speed brake and the flaps decal, and the stab trim decal. So if we turn it round to the back, we've got a 12 volt LED dimmer. I'm going to guess that's for the backlighting. We've got a red, black and white 3-core cable here. Not sure what that's for, we'll get back to that. And then we've got 2 USB cables. I'm going to guess those are for, yep, one for the Arduino, one for the Leo Bodno, which would be the axes. Oh yes, we've got servos in there. And it actually looks like the trim actually might work. That's cool. I can also see in there a parking brake solenoid. Very cool. And as you can see, we've got a fidgets card here that isn't even connected, or it requires a USB cable. It's going to require power. I'm not sure though where that's connected to. What's it got on here? Trim motor. So yeah, that's going to drive the trim wheels backwards and forwards. We'll have to give that a go. So it does look a bit messy on the inside, but we'll see what we can do. I'm going to guess this bit of wood here that's fallen off isn't supposed to be there. For such a simple design, it's going to take a lot of work to get it up and running again, or get it to a decent standard. Hang on, is that wheel turning by itself? It is. I don't think that's right either. It's just unscrewed itself. Okay, there we go. And let's connect the backlighting up to see how that looks. Now I've got this 9-pin adapter here. We're going to cut the 9-volt part off. Off that goes into the bin. Let's get some wire strippers. 1, 2. Let me just confirm, yes, 12 to 24 volts. Let me turn my power supply on. 8.2 volts. Let me just turn this up. There's 12. And can we see anything come on? Oh yes. So you can see the flaps decal is fully lit. That looks really good. Same as the speed brake decal. That looks really good as well. Coming down, we've got the stamp trim decal. That's not currently lit, but it looks like it could be. The fuel decal's not, but the parking brake is. The stamp trim indicator decals, they're not, they're just stickers. I can see that from here. Let's turn the power off. We know that we've got the two main decals that light up. Okay, so that can go off there. I definitely think the first job is to rebuild the throttle levers. I've got two options. I can go really simple and give this back to Jonathon with 3D printed plate here to replace that. Rebuild the throttle. That would actually be quite easy. Yeah, I think that goes on that side. So I've made the call. I'm going to take this back cover off so we can see inside and see if we can make these throttle levers completely replaceable for Jonathon by giving him a 3D printed version that if he wants to replace the whole unit, he can. So let me see how easy this comes apart. Will this come off? It will. Oh, well, that makes that nice and simple. So there goes the LED dimmer. That comes off nice and easy. Can we get this off completely? Not quite, because that's attached to the board. So that is the 12 volt power. That is the junction box for it. It's on with hot glue. Hopefully I can pull this off without damaging anything. Yep, there we go. Good. Don't actually need to take that off the cables, even though actually I think it is quite possible now. Well, that makes sense. So that goes to the Arduino. We've got a fidgets card here. It's the motor controller. Okay, that makes sense. I've never used a fidget, so I'm not sure how it works. I am really tempted to remove this board so we can sit it down straight. Now, I'm not too fussed about the wiring. So there's the common ground, it looks like. Yep. Well, we don't need that USB cable. That can go. Really don't mind about that USB cable. And they're nicely labelled anyway. Right, so here we've got... Whew, so that's the RX analog axes. I can only imagine that either went to his tiller, his rudder pedals, or it could even be his yoke. Right, well no, because yoke would need two. This is coming out. He says we can do better than that. We can give it back to him in a much better state. We can create a dedicated 3D printed insert that goes in there with all these mounted on properly and not on broken bits of MDF. 1, 2, 3. Right, that tidies that up and it gets rid of that assembly completely. Where am I going to put it? I need a box. Bingo. This box of pieces can go there. Fidgets. Now, where exactly do you go? So you go directly to the motor. There's the fidgets card. There's our motor lines. These are just servo extension cables. And that's what the Arduino was for the servo. Right. And the other servo. Let's take these trim wheels off. And they come off like that. Back you come. So I've taken that trim wheel off here and we're missing the gear that goes to the 10 turn pot. So there we go, we've got a pot that turns 10 times, which allows the motors to spin. Off that comes. That should be a very easy fix. We can reprint the gears on that, not a problem. I'm just not sure of the feedback loop between the fidgets card and the 10k pot. If he's got ProSim, that shouldn't be an issue. We'll soon find out. Good. How's this part going to come off? Now this might come off in a whole oneer, which would be lovely. So, going to hold the shaft. Yes, we can. There we go. There goes the trim wheel. This nut was held on with a bit of hot glue. That gives us a lot more access, and it looks like these are just side shells, so really cool design. Like that, how the whole section now falls off, and we can simply disconnect the servo. Brilliant. I think that this section's going to come off next. It's held on by that one screw. Wow. Nice. Out comes that unit. Again, servo disconnect point. Just recently I remember Jonathon saying that the solenoid valve I don't think has ever worked, and we can tell that because it's never been connected. But I also have my doubts. Now I've worked with solenoids before. This is only a 12 volt mini one, and I have my doubts that that is strong enough to pull against a rotary switch. That's quite a lot of force for a 12 volt solenoid. What we'll do is we'll get this bit off here and we'll give it a go. We'll put the power supply on and see if it's strong enough. So I'm just going to pull the parking brake lever off. Can I twist this round a bit more to release the parking brake lever? I can, there we go. Okay, and we've got a little parking brake LED there. It looks like it's been adapted to go with a 3 volt LED. So hopefully you can see that here's the solenoid. Here's the rotary switch. Let's connect the linkage back up. And that's parking brake on. Let's see if we can apply 12 volts. Oh, this is solid strand wire again. Here we go. So let's see if this lever moves back with the solenoid. Not a chance. I'm going to up the current. 1 amp. Now I really wouldn't want to be using this on the... Nah, don't want to push it any more than that. And what I'm going to do now is 24 volts, which is double its operating voltage. I'm going to halve the current. So I'm going to go back down. I'm actually going to go back to 400 milliamps. Oh. No. How hot is it? It's still cold. There's just no way. There is so much force to change that rotary switch. Right, that is never going to work. Sorry, Jonathon, I just don't think that design is good enough for getting that solenoid to work correctly. So what I'd really like to do right now is just get one throttle stem out so we can recreate that in a 3D printed design and hopefully insert it, and it will make it just a lot more rigid. We really are now getting into the guts of the unit, and I really don't want to take everything apart. Just don't have time. Well, let's take... I say I haven't got time, but I'm really interested in how this is done. Don't get me wrong, this I would say it's a beautiful design. It's done really well. I just don't think it's the right material. Well, that's a lie. The material they use has got a really nice finish. Obviously bends nicely, it shapes nicely. It's just very soft, and hence why we've got broken parts, which is why I want to try and 3D print some of the parts to make it a little bit stronger, and then if they do break in the future, it can simply just push print again. It's actually very cleverly designed. Yeah, it is. Right, what we're going to do, let's take this motor off. Wow. Can I take the chain off? Oh, I can. Look at that. That was nice and easy. chain, gear, washer, and that's... So I guess this is a giant threaded bar that's hollow, and I've not seen that before. I mean, that's a really good find, whoever found that. I am just looking for the easiest way to break this down. Let's take the parking brake off before I break it anyway. There we go. I am now just wondering if the whole thing is made from balsa wood. Perhaps. That's got me perplexed what the stuff is. Okay, so how would I get this unit off? That has to come off, that has to come off. Damn. Aha, that is for the LED lighting. That's cool. That's for the pot, for the speed brake. Yeah, we can see how that works. It's got a really nice feel to it. I'm not sure how they've created that friction, but it's certainly not floppy. That would stay in any position it's left. I'm going to do it. I'm just going to cut the LEDs off. Now the reason I did that is I will replace the LED strip and put new wires on and not use solid core wire. Good, that gives us access to this plate now. I think we are going to have to take the dust cover plate off. Now this may look a bit harsh, but I've got no intention of putting any of this bottom stuff back together like it is. Wow, there's some serious cobwebs in the bottom, because we can 3D print a specific mount that holds all this in the right place and make it just look a lot better and a lot more professional. These are just buttons, so nothing matters where it goes, especially on a Leo Bodner card, which is fantastic. Just going to pull all these out. I've forgotten how sharp the Leo Bodners are. The soldered points that come out the bottom there are just so sharp. There we go. Leo Bodner in the pot. Here we go. That gives us a lot more access. Got one screw there, and then we might get our first throttle plate off. There goes that. That can come off. There we go. And there's our fuel cut-off lever, the micro switch for activation. Beautifully painted. It's very soft, and now I know why. It's because it's only got elastic bands operating it. Now, I don't know if you know, but the problem with using elastic bands is that they tend to rot over time. So there's our throttle lever. All we've got to do is undo this nut, I guess. And I guess that nut sets the friction of the lever. No, not at all. That is actually quite a stiff lever. And you can see that it's still on here. Now how does this come off? Okay, I can see another screw. In there. Let me pull this off. Now is this throttle plate going to come off? No, it's not, is it? Okay, so it still feels quite attached. Yep, there is definitely one hiding in there. Come on, out you come. Ah, it's glued as well. Oh no, it's not. It's screwed from underneath and on top. Okay, that takes that plate out. This takes the cover plate off. There we go. And we've got both throttle levers. Nice. So let's see what is setting the friction on these. I'm going to guess it's these plates here. I like. Off comes the cover. And that is exactly what it is. Wow. I like it. So let me put what we are going to do. Is I really want that screw out. I want that micro switch off. It's been hot glued in position. Yeah, there we go. Worst case, we can glue it back in position. There we go, that's done. That's done. Beautifully made, it really is. Okay, let's see what we can do. I think what we need is a ruler. Right, I'm going to place the ruler down. There's the 0. Let's make sure we've got the on the axes. So 0. Oh, so it's 25.6 or 256 millimeters long. We're going to get the camera. We're definitely not going to have it on Instagram mode, which is 1:1, and we're going to go 4:3. We're going to look directly over the top, get nice and close. Where's the cameras? The camera's in the top left. Looks kind of straight. There we go. Got that picture, and just in case, we'll take another one there. A bit closer. There we go. Right, I've got the photos. Let's jump into Fusion. Let's see if we can't create this in Fusion, make it 3D printed. So here we are sat at the computer, Fusion in front of me. Now this might be a bit boring for some people, but if you want to know how I go about designing parts for other people, this is how we do it. I'm going to create a new sketch which is already open. Let's insert that picture. So it's going to be a canvas. And it's going to be from my computer. Then it's going to be under pictures, Samsung Gallery, DCM, camera, and hopefully there we go. I'm going to try that one. Yep. Onto that face there. I'm going to hit OK. Now, is that going to be upside? Oh, it doesn't really matter. Which way does our ruler go? Perfect. Click on top to get it absolutely parallel. Open the canvas tab. And in here, we're going to go calibrate. And then I'm going to select it on the 0. I'm going to go all the way to 25. And then put 250 millimeters in. There we go. Now that should be pretty close to what we've got. I'm going to lock it back into the top. And just to make sure we get this right, I'm going to push C for circle. And right in the middle here, here we go. Here goes our drawing now. And let's measure the hole. I would guess it's about 40 millimeters. Okay, so it's 41, 41. So it's 41 millimeters. Okay, measured with the calipers. We're going to drive a line from there all the way across, which is cool. And now all I've got to do is draw around and create the unit. We can do an offset here. So if I've got it in front of me here, I'm just going to measure the distance. So 6.9. Let's just do an offset. So O for offset, 6.9. Perfect. I am going to use this as the center line. I'm going to draw a line here. Yeah, make sure it's parallel. A line there. A line there. I'm going to draw another line here. Right. I'm going to do it from up here, in fact. There we go. Perpendicular. This goes to there. Yeah, good enough. Oh, it does have a circle cut out. Right, so we can go from the centre here. Perfect. And we can bring it to there. I'm going to bring it... We've got a bit of parallax error in here. So that's fine. Just going to extend this line down. There we go. That's going to go somewhere like that. Line. That's going to go somewhere like that. Right, let's see if we can tidy this up. We're going to zoom in. Yeah, bring it to there. This one to roughly there. I'm quite happy with that. That all looks pretty good. Okay, let's put a C in here for circle. Let's get it round. We can measure that. Let's see what diameter we've got. 14.9. It probably was 15 originally, but with a bit of sanding, and I'm going to guess this might be laser cut. Yeah, I'm going to bring that out. We'll measure this again to get the dimensions right in a minute. C, going to be on that line. What dimension have we got here? 11.9. Let's put another C in here for circle. Sorry, I don't know why I'm saying that. Oh. Now I do think yes, that's a parallax error. So C. Let's bring the. Well, I'm going to go from there. I'm going to zoom in. Join that line. That'll give me the midpoint. There we go. Midpoint. Drag a line out, and then we can get the C in there. Take it out to there. So that's 19.7. Let's see what the calipers say. 19.8. Ah, close enough. Alright, let me put that back on. We're getting our basic shape. Right, let's just move this so that's it. So it's touching there. And there. Good. We draw another line. You're going to go from there. Let's make sure it's a tangent. So we're going to click on the circle, click on the line. Perfect. I like that. I like that. We have got a circle there and we've got a bend there. Okay, we can sort that out now. If I was to draw another circle there, a little bit too big. Let's go there. Let's grab it and move it into position. Yeah. That looks good. Oh, I've missed a major line out there, and that is this dimension here. I think we're there. That's going to give us our block assembly. I'm not going to worry about fillets just yet, because we can do that in the 3D printed part, in the 3D extruded part. Okay, so I'm going to push E for extrude, and then we're just going to select our major sections. I've forgotten another line, so I'm going to cancel that and press L for line, and it wants to go somewhere along there. Does that look good enough? Get off. Going to drag the line in just a little bit. That's good enough, I think. Okay, let's try that again. E. It's just like paint by colours, really. We'll come back and do all the detail in a minute. I just want to create the block that we're going to cut into. Yep, yep, yep. Oh, I've got a smidge in there. Right, let's measure it. And that's the thickness that we require. For some reason it's got 10.2 on the back, so I'm wondering if it is 10.2. No. It's close enough. It's 10.4. There we go. 10.4. Done. So we're going to need some mounting holes. See, and I think we'll go with 3.3 to start with. There's only one way to do this properly, and that's to draw a line from there to there. Go to the midpoint. There we go. 3.3. This should auto highlight. You're going to be 3.3. You're going to be 3.3. I'm actually going to come back. This is actually going to be the screw holes. We're going to put brass inserts into here. So we might as well do that now, because this is the mating surface that they screw into. And they're actually going to be 6.3, aren't they? Yes. 6.3. Or have I just made that up? Do you know what I'm going to do? I'm going to get a tapered insert and measure it. Really glad I went and got the taper insert. Is that going to focus if I take my face out of it? There we go. Right. I forgot I'm using M3 inserts and they're tapered. And they're going to go in at about 4.3. So it's actually reading 4.6 or 4.3, yes. So we can just quickly change that to 4.3. There we go. 4.3. What others we got? We've got 1, 2, 3. Let's just quickly change that to 4.3. Get off. In we go. 4.3. There we go. Oh, we might as well put them in now. Okay, I'm happy with that. E. And we're going to select our 3 holes. These have got a taper, so it's going to be -8. And how deep are these? I think we're probably going to want 8 millimeters. Yes, we are. So 6, 2 extra, 8 millimeters. 8 and 8. Let's have a quick side-on look. I've gone the wrong way, so it's distance -8. There we go. And I'm going to go back onto that, and then I'm going to go 3.3, 3.3, and 3.3, and drag them now down -8 as well. Oh, something went wrong on that one. Come on then, where are you? Did I not draw you? C, 3.3. -8. Good. So then we should have a chamfered hole going into a straight hole. Because I know I'm going to use these holes now, I can put a fillet on them. So 0.6. There we go. Now let's make it look a bit prettier. So we can put a fillet here of about 5. Yeah, lovely. And I'm going to say a fillet here, here, and get off here for 5. No. I'm happy with the top 2, but not that one. Yeah, I'd be happy with that. No. Let's go 3 perhaps? Yeah, 3's better. A fillet of 2 perhaps on this one. I'm going to go 1 now. I forgot what I used. It's actually quite a small unit. Fillet, definitely 2. There we go. Make that look a lot prettier. Let's match the opposite side now. 2. I'm going to guess it's going to be 1s. Can we get away with 2s? Yeah, we can. 2s looks pretty cool. Fillet. I'm going to go 15 here. Okay, let's try 5. Yeah, 5. That's good. That's good. Whoa, that is not good. We've got an inconsistent join. If I push delete, yes, it joins it. Good. Fillet and fillet. Let's make that 2 perhaps. Yes. That makes that look nice and neat. Round here. Now this is usually quite a big fillet. 5. Yeah, 5 will do. So now we need So now we need the middle part cut out. Let me line it back up top dead center. There we go. Line. And we're going to draw on this top surface here, and we're just going to follow the cutout. There we go. That's that one. Now we don't have to be too accurate, because what we're going to do is we're going to replace this part completely. So as long as the base unit works and all the dimensions, the cover plate and the knob plate are going to come from this anyway. So it really has no effect. And you'll understand that as we get a bit further on. Arc, 3-point arc. I'm just going to go from there to there. Drag it out to there. Good. A line from there to there. So we're going to extrude that down. It's going to be a minus 10.4, which is the thickness. Then we're going to add 4.55, which is what the thickness is. Hit enter. Cool. That cuts out the section in the middle. Yeah. Fillet. This bit here. Let me just have a quick look. And that's going to be a 1. There we go. Fillet here of 2. So next, because we've got that cut out, I'm going to now select that plane, and then I'm going to put the circle in. There we go. So it's 9.7. 9.7. And it comes up 7.7. Okay, E 9.7 minus 4.55. There we go. I believe that's got a brass insert in it, and that's going to be 4.3 E. Taper angle of -8. Distance. Oh, this is going to be tight. -6. Yeah, okay. C 3.3 -6. Good. Good. So there we've got a taper going into a blind hole. It hasn't gone all the way through, which is a bonus. Mind you, even if it did, that isn't going to be an issue, because I've forgotten we've got the outer plates to go on. Okay guys, so instantly we don't have the depth to be able to screw all these parts together. So we can't use brass inserts. Delete. Away they go. Delete, delete, delete. I've come up with another way, and that's how I do my throttle lever handles. And that's to use nuts and bolts. Okay, good. So with that said, let's pull in the sketch again. Now, which one was that? I think it... Edit sketch, and we're going to change these to 3.3, 3.3, 3.3, finish sketch. Yeah, that's taken, hopefully they've gone all the way through. Let me just turn the canvas off. No, they haven't, but we can easily fix that. Just by selecting the surface there and getting him to go all the way through. Good. And get rid of you, get rid of you. That's 3.3. Perfect. Cool. What's next? Micro switch. Now, let me see if I've got this size micro switch in my library. I doubt it. It's not something I think I would use. Micro switch. Hit enter. Ding, ding, ding. Just having a quick look through. I knew it. So I don't bore you, let's time lapse this next part. And what I'm going to do is I'm going to draw up the micro switch so we can get it fitted correctly into the handle. And we're back. And we're back, guys. Okay, micro switch designed. Should be close enough for our usage. All we're going to do is go back to here. I need to create this cutout here. Now, there's a cutout here that housed the micro switch. So let's just find that again. As we can see, we've got a line kind of there. I'm going to offset that, drag it to kind of there. Okay. And then another line, because we've got this one that goes all the way back. Going to just zoom in a bit. There we go, to there. E. Oh, it needs to go down even further than the surface. Okay. No, that definitely is square or perpendicular. So let me just correct that. That's more like it. Yep. Good. E. Let's take this down to this surface and then a minus another 2 millimeters. Did that go the right way? No. There we go. And then add 2. I had to pick the wrong minus 2. There we go. Good. And that's created. And that's created this recess here. So let's get our micro switch fitted. We need to insert that design. Let's just close this out. Refresh the recent things and the micro switch. And now the micro switch should be at the top. Let's insert that micro switch into this design. It's actually back to front right now. So it needs to be like that, 180 degrees. Let's just drag it forward. There we go. Let's make it so it's parallel, 5 degrees out there. There we go. And it currently sits a bit like that. Let me just check. That's exactly how it sits. That's good. Okay, so there's a few things I do not like here. Well, that probably one reason is that it's sat on the wrong surface here. So let's move it. Cancel. Micro switch, move. Let's just bring that up to the surface. Hit OK, catch a position. I think before we go any further, let's save that. I have a real bad habit of not saving and then losing my work. There we go. Right. We probably could add a bit more detail in now. So I'm just grabbing the push button. And that definitely is your standard 6mm push button. Now that push button is your standard 6mm. Should have that designed already. I thought push button was going to come up then straight away. Push button. It's definitely not a... Well, I'm not even going to pronounce that. Push button. Push button with joints. Do I want that? Yeah, I probably do, don't I? Insert into current design. Proceed, yeah. Okay, now what orientation have I got this in? Just 90 degrees out. Good. Bring it back. Let me just hide it there for a second. In fact, we'll move it there. Hit OK. Because we can already see that we've got tracks going in. So, catch a position, line. Really didn't want it to go that way though. That's the way I wanted it. Now, because this is going to be 3D printed, can we make this a little bit better than what it is? Let me see how they've done it. They've basically just pushed it in, which actually is quite clever. And I've got to admit, you probably can't see that on camera because I'm using a webcam and it's quite difficult to get it on. Right, there we go. Can you see that? Oh, I don't even know if it's going to focus. There we go. Right. So it just pushes in. And actually, I quite like that design. That is simple. Simplicity at its best. So line. Line. Okay. Now, I'm just going to measure the dimension of 6.7, 0.2. So let's go 6.95 between the two. That should give us plenty of wiggle room. 6.9. Yeah, there we go. And he's got a wire trace going all the way. So we've got this big circle here, which is a cable pass through. Let me see what dimension it is. I might as well match it. 9.3. Got a line. It does go from there to there. And then let's zoom in so we're not trying to snap to the grid. Yep. Okay, offset. What we're going to give you, we're going to go about there. 4 is 4mm gap. That means we can offset this by -4. That creates our wire way for there. Then we've got one down to here. Yep. And then line. To there. Offset. 4. Offset. 4. Just going to drag that out a bit. Oh, are we not stretching this line, are we? We're not, are we? Okay. There we are now, though. Bring you down. There we go. D. So I'm just going to set this back 3mm. Oh, that's only... There we go. 3. Then we're going to need that bigger chamber. But let's put the base in here. Yep. Another line. Now we're going to create the barrel section, which can be as big as we want, really. Right, line. Line. E. Right, minus that. Minus that. That and that. Cool. What do we want that minus? So initially we want it... Oh, okay. 10.4 minus 7. Minus 10.4 plus 7, which is actually 3, isn't it? That's all good. We haven't got that hole, so let's put the sketch back in. E minus 20, that's going to drag it all the way through. There's our chamber. Right, so from this chamber it needs to go much deeper. Yes, it does. E. Minus 10.7, so let's go minus 8. That's cool. Let's make it look pretty. And how deep have they got this hole? 3. So 10 point, so it's going to be minus 7, isn't it? E minus 7. Ah, wrong way. Is this what I wanted? Minus 7. There we go. Let's check our dimensions. 3.4. Yeah, E minus 0.4. Fillet. Now this should be 3. No, not 32, 3. Does that look about right? Yeah, I think it does. Let's just make this look pretty. 1, 1, and 1, 1. Yay! Good. No one likes square edges. Right. Let's hide that sketch. That's what we've got so far. Let's make it look pretty again. Let's make it in white. There we go. Still got the gear to do. I'm not going to worry about that just yet. Coolio. Next important thing is the... Let's design this lever next. Whew. This should be quite... Well, it should be easy. So let me turn off the canvas now. I don't think that's going to be any good to us. Let's construct planar angle. There we go. 90 degrees. Yes, please. Let's construct again another planar angle. $90. Going to split the body. One there, hit OK. Hold that side. We're going to grab this part. Turn the sketch off now. Good. Let's get rid of the construction lines. Find in browser. Body 2. Move to about there. Yeah, that's cool. Just going to hide that bit. This is going to make a mess. Right, I'm going to try a loft. Catch a position from there to there. Bloody hell. That actually worked. I like. And then if we just fillet this with something big like 15. Yeah. And the same to the side. Would I? Is it 15? Get off. Let's just fillet that again and see if I push 15. What do we get? We get quite a good shape. Whew. A bit like that. Okay, so let's make it look a little bit prettier because these don't have to be right angles. These could be ones. Yeah, that's better. These can be twos. And I would have said to do the... Oh, it's not going to like this. 1. That may be a little bit too substantial. Let me see if it'll give me the side. We've got a part that isn't selected. I can't believe it let me do that. Okay. That's going to be okay. I'm going to put this on here. Fillet 0.6. Fillet 0.6. Too big. Edit feature 0.4. There we go. Righty tidy. Let's save that. Jonathon. Thrust lever. Hit OK. My recent data. Let's refresh the list. And now hopefully we can drag this lever into the throttle lever. Here we go. This is probably where I find I've created it back to front or something. Insert into current design. Okay, well I may have just created it at a funny angle. We'll keep going. 180. Now let's move it to point A to B. Boom. Well, there's our first problem, but that's fine. That's completely okay, he says. This is where we get to modify our angles now. So, Jonathon thrust reverse lever. Let's go Control C, Control V. We're going to rotate it about this axis and we're going to drag it up. Look at that. That wasn't bad. Okay. That's really quite cool. Let's drag this one across now. And we're going to rotate it down. So it's hard against there. Okay. Let's just change that to 44 degrees. Now, is that... Oh, that is parallel. That is beautiful. Wow. I just don't think I'm going to change that. I'm going to change this. So this is thrust lever 2. I'm going to move it back. Right, so let's not move. I want to move it. No, okay. I'll cut that up. Push M. I'm going to rotate it around the pivot point. Not 1 degree. 5 degrees. I want 1 degree. Yeah. Come on, let me try 2. Degrees. And how does that look? I like it. Okay, 2 degrees, catch position. No, that's fine. So it's definitely pushing. I still think that might create a bit too much. Right, move, edit position. I'm going to change it to 3. No, Control Z. You're not going to let me, are you? Okay, move. Select axes. And then 1 degree. Better. Right. Now this is obviously the stop, so I'm going to delete the fillets here. And I'm going to drag it. Let me select it. Come on. There we go. E, catch a position. Now what distance are you? I have it. I'll take it. No, actually 1.5. No, 2. Right. 2. Join. And what we're going to do is delete this surface here. Good. And we're going to split this body. We're going to split it with that surface there. And we're going to split this section with this section. And what that's done is create a bit that we don't need. Find in browser. We're going to remove that. There we go. So that is the stop, which means the lever is hitting that before it starts to hit the micro switch and interfere with it. Let's now reassemble the 2 split sections, the 3 split sections, 4 split sections. Okay, perfect. And yeah, that looks good. We can put our fillets back in here. A nice big juicy one. Yeah. Now you can see that we've got an issue here. And that actually is... Yeah. Let me find something to point with. We'll use the depth gauge. Okay, so the problem we've got here is when that goes in, let me put that in. You can see, in fact, this is actually contacting the edge here, and it's actually causing a bit of friction. Let's see if we can get this right. There we go. But right here, no, let me get my fingers out of the way. So on camera, right there, there actually is a half semicircle cutout. So I am going to create that. And because this is going to be a large print piece, in fact, I don't even know if this is going to fit on the printer, is it? Oh, that's going to... This might require an SBM, a small printer mod. We'll worry about that in a minute. Okay, so we've got that. We're going to drag it out to 32. So anything in that range needs to be deleted. So let me get rid of those. What I don't want is it to delete that. So let's just take that out of the equation. And then that out of the equation. Okay, finish sketch. Get rid of you. It won't affect them anyway because they're a component. Perfect. Is that microswitch a component? It is. That's fine. Down to face. That's going to cut that. But we also need to go the other way. So two sides, grab the other arrow, bring it up, hit OK. And let's put our components back in, and there's a nice steady gap there. We actually could get away with going a lot less here. So fillet, let's put a 25 fillet in. Well, way too big. 12 is too big. 8. 8 is actually not too bad, is it? I think that's what we needed. Okay. Right. Back to small printer mod. Now that I've thought about it, let's see what we can do. Okay. Small printer mod. Well, I guess the first thing to do is just to grab the whole component, which is body 1. Yeah. And send it to Bamboo and see what it thinks it can do. Hit OK. It definitely looks like it's too big. So I'm going to bring Bamboo in. This is the Bamboo slicer, and we're just too big, but that's absolutely fantastic because we all know, if we've done mathematics before, that if we rotate it, that is going to fit on the build plate in one piece, which is absolutely fantastic. Oh yeah. Right. So we don't have to worry about that. We can keep going. So I have to say that it's so good being back at designing again. And I know what makes this even simpler is this is based on somebody else's design. So the gears, let's just measure what that could be. So see, it's about that kind of radius. So a 78 radius, diameter. Here we go, 78 diameter. So if I remember right, it's been a while since I've done this. Shift S. Yes. Good. Right, so there's the script add-in. Right at the bottom, you get this by pressing Shift S if you didn't guess. I like the spur gear one at the bottom. Okay, that's all good, that's all good. Module, so module 1.5. Number of teeth. Wow, root fillet radius needs to be 0.2. Gear thickness. Wow. To be honest, we might as well make it the thickness of the gear lever, which again, if I remember right, is 10.4. So, 10.4. Oh, we need a hole diameter. Now I can't remember what that was. Was it 41? 41 it was. 41. So our pitch diameter is only 36, so we need double the amount of teeth. Let's go 50 in fact. So, oh, we're close. What did I say? Oh god, I'm really getting bad with memory. 56. 80, way too big. Too big. 52. 78. I like 78. 51. 76. 75. I think 76 is what I wanted. Okay. 50. The good thing is that I can hit OK. There it is. Then we can just basically switch that sketch off wherever that's coming from. Oh, I am in a sketch. Whoops. I didn't mean to be in a sketch when I created that. Sorry, guys. Move A to B. Look at that. That will do, donkey. Catcher. Now what we're going to do is press Shift S again. Back to spur gear. All the settings are saved. If we've got 51, right. So 51 divided by 3, 17 teeth. We need a gear with 17 teeth to give us a 3:1 ratio. So we use the full pot distance really, or as close as we can get. We can add a few more if we want to go bigger later. So we said 17. That's going to give us a 25mm. The diameter is too large. That's fair enough. Well, let me go 4, and then we'll adjust the size of the spur gear later. Let's just see what that looks like. Hit OK. Where is it going to put perfect? I haven't moved that off the plane, have I? No. So let me just hide the canvas. There we go. Now we can see the pitch diameters. Just going to rotate this. Move. Not face. Cancel. Spur gear. Move. Rotate around axes. It's probably. Oh wow, 5 degrees is perfect. Hit OK. And then we're just going to keep coming down. So that would be dead on meshing. But I find that that is too close. So a 0.2mm gap is usually better. It's not going to move now, is it? Oh, it is. There we go. Let me get directly on top. There we go. The teeth aren't as lined up as I thought they were going to be. There we go. I like it. If I go to measure, and we measure that to that, 0.12, that will do. Good bit of backlash. Okay. Well, realistically, I think what we could do is go for a test print. I just realised that they are half gears. Can we see it? There we go. I really must get this camera knack sorted. There we go. So they're half gears. Because we're going to 3D print, we don't have to make it out of a different material, and we don't have to glue it in. Let me orientate this the right way. We've got it that way. So it's this half that we need to keep. Straight down. And it is slightly past. So that's vertical. Yeah. Let's just draw a line here then. Catch a position. Yeah, that's fine. We can draw a line there. And there. Finish sketch. Now, so I don't damage this gear in case I want to make an adjustment later, I'm going to press Ctrl C, then I'm going to paste new. Hit OK. I'm going to hide the full size gear. Then I'm going to click that. I'm definitely going to hide the body. There we go. E, drag it down, enter. It's gone. Put the body back on. And ooh, if I made that a component, hang on, let's make that a component, which it should have been from the start anyway. And if I drag that gear into the component, that means when I go to print it, so save as mesh, Bamboo Studio, here we come. Right, I think it's about time we got this thing printed. Let's get our first test print done. What we've got to do in Bamboo Slicer is highlight it. Let's rotate it so it fits. 45 degrees should do it. Let's slice it. I think all standard settings should be fine just for the prototype. Faster the better, really. Yeah, that looks good. Quick uppy down. Just make sure that the support is going to work. If there is any, I don't think there is any. Cool. That makes it a nice simple print. Hit print. In fact, both printers are busy, so as soon as one's free, I'll hit print. I'll catch up with you guys shortly. Let me give you a quick update. Here is Jonathon's balsa wood throttle lever. I'll come a bit closer. So here's his throttle lever, and what we did was took a photo of it, reverse engineered it in Fusion, and we ended up with this version here. No, we didn't. We ended up with this version here. There's quite a few here, and they are actually quite identical. Obviously, there we go. So I thought I've gone to all this effort to take it apart to create something that is okay. I mean, it was a good job. Don't get me wrong. I've been happy with it, and it actually looked quite impressive before I took it apart. And that now is rock solid. These are balsa wood. I think 10mm balsa wood. So they're very fragile, and that's the reason why Jonathon sent it to me. Is because there's some broken parts on it. So after spending a night reverse engineering his throttle lever, I thought, we can do better than that. What about if I cut the head off the version 5 MTU and put it onto the shaft of his? So that's what I did. And now we've got this one here. We've got a proper unit. And of course, then I realised, wow, we can go further than that. And because in the MTU, you remember, you've got all the workings in the base. Well, simplified it really. Here comes the next version, and this will make you laugh because I know on Discord this happens a lot to everybody. It also happens to me. So, Jonathon's thrust reverser worked from having a micro switch, and it just keeps it simple: on off the thrust reverser. So I've kept it there in the base, in the handle. It goes against the lever of the throttle lever here. In fact, here is the version I created last night. There's the micro switch, and as the throttle, the thrust reverser is opened, the micro switch opens, and that works fine. I don't have a pot, but there is a pot. The second version, now the more updated version, is to have a pot in the arm here. So the pot just simply slides in the back. It's not required, so you can have it either or you can have both. And then our thrust reverser goes into the base here, and let me show you the center panel. Here's the center panel. Perhaps if I get it the right way around, here's the center panel for the one side. Now what's special about the center panel is it's got this slot here, and this is the thrust reverser slot. So the arm fits in, and I hope you can see it in there. There's a little, I'm going to call it a nodule, sits in there, which means you can't move the throttle reverser, now the thrust reverser. As you can see though, there is a bit of play, and I didn't like that, and really puzzling how, because there's so much mechanical advantage that you can apply over this lever into this point here, how to restrict it. Now MTU version 5 had a little rod in the back, may even have to go back to that if this next version doesn't work. So anyway, what happens is this goes all the way back into idle, and then because that slot's there, it allows the thrust reverser lever to go all the way up. You can't move the lever forward until it's fully down, and then it moves forward. So that's its principal operation. I've got a new version, which hopefully it's going to take away this play here. We're going to give it a go. All I've done is I've moved the, what would you call that? The pivot point 10mm to the right or anti-clockwise, so it's already hitting that point. We'll have to find out and see. That's the whole idea of this next point. So this one I printed with the infill, the channels all inside I printed. I didn't put select, touching bed only on the support. So this one has got all the support inside, and you just can't get rid of it. It's useless. However, I'm glad to report this is only a 1:30 print, so that can go in the bin. But I'm actually going to save all these bits just to show you how many revisions I go through to make a simple project. Right, and what we've got here is this version. This time all the channels are clear. We've got several other modifications that I did. I can't remember what I did, but there were just slight little tweaks to get it absolutely perfect. And I think what I've done is I've put the camera on, nearly poked you in the eye there, put the camera on, and we'll see how this goes. We're going to build it live on camera and see if it's any better. Or we're going to revert back to version 5. Let's do it. So the first thing is to take off this pre-mod adapter plate. Now, the reason why there's an adapter plate on this side, this is the center frame of Jonathon's throttle. And so that you can print it without support on the back, we've got the raised plate for number 2 throttle there that prints flat. But this one has to be added so you don't have to print all this with support. You may also notice that I've put lightning holes in. This requires less PLA and is obviously faster to print, so that's why it's got such a unique shape. So here's our shaft adapter. Make sure I get it the right way round. And we now need countersunk screws. In theory, that's going to go on there like that. It's a nice snug fit, there's no play in it. Here's the cap, and what we're going to do, so we can apply friction, I'm going to laser cut a bit of cork that goes on there. And the more we tighten the cork down onto the lever here, the more friction it's going to create. There we go. But we're not going to do that right now. In fact, we could probably just steal these. Let's build the throttle lever first before we attach all this. So first up, we're going to take the micro switch out and reuse it. There we go. Grab the soldering iron. And I've just realised the soldering iron was full of solder, which probably means I won't be able to reuse this. There we go. There's one. There's two. So there's the first error. I've not tapered the hole for the insert. These are much bigger because they're meant for plastic 3D printed. So, are we going to get that in there? So first off, let's make sure it fits in the throttle. It does. Good. So that's how it works. You also know it's got a recess here. And there is a recess in the front plate. So all the pressure is taken off the pot, and it's all the pressure is taken by the spacer and the outer plate, and it basically pivots inside those 2 points. We just use the pot as the direct feed. Now I did try to use an AS 5600, but they're just too big to fit in this little space. Okay, let's get that brass insert located back in here. Let's see if our screw now goes in. We could take the thrust reverser arm off. There we go. Ah, now there's still gunk in the pot hole. Support material, that is, by the way. Let's see if I can get this out. So there's the pot installed. Let's get the arm on, just make sure we've got enough room. So kind of centre axes. Centre. Yep, that's perfect. Okay, that looks good there. So let's just see how this reacts. So it's going to go on like that. So I'll show you a bit closer. We've certainly narrowed it down, but there's still about 5mm worth of play. I think that's as best as this design's going to get. I mean, wow, you can force it all the way around. We definitely need that bar that locks it into the base there, I think, moving forward. Jonathan, I think I'm going to give you this version. I mean, you can't really get it on, and the micro switch doesn't activate. The pot, you can just null this area. You've still got all that action there, but you can move it by about 10 degrees, I'd say. Again, that might be the plate in the bottom shaft here. No, I don't know. I need a lot more thought that need to go into that. Ideally, what I need is a real 737 throttle to take it apart and reverse engineer it. Let's carry on with this build and see how far we get. Next is to test the micro switch fit. This was adjusted in the last version. So in goes the heat insert. And that's how the micro switch works. So when it's in the slot, you can hear that when it's pushed in and down, that's the micro switch off or the thrust reverser off, and then it opens up as the bar moves away. There we go. So the micro switch is in the perfect place now. That's good. Got more brass inserts in here. Here's the new back plate. On this version, I forgot to add the micro switch dome recesses here, so it doesn't sit flat. This version, if I don't drop it, has that recess there. That should go on the back here, and it fits absolutely perfectly, which is what we like to see. So we can definitely get some brass inserts into these holes. Not that hole, that's for the other side. Okay. So if you remember from the MTU, a ball bearing goes in here under spring load. That locks this in the idle position and gives you a detent feel that comes out of the gate, so you know you've pulled the thrust reverser out of the gate. Yeah, it's a shame, I really can't get rid of that play. Oh well. Sorry Jonathan, I think that's the best this version's going to get. It needs a really good think about how we're going to do it moving forward for the MTU version 6. So I really want to make sure that the back plate fits. That's going to go on there like that. We're going to need some screws. And because I changed the shape of the handle here away from version 5, I've had to reprint the throttle knobs, so these are different from MTU version 5. Going to need a brass insert in there, and the same for the thrust reverser. Obviously these are double depth because I've increased the thickness of the thrust reverser arm. And even though I've done that, I still think it looks quite good. And it is, of course, rock solid now. So there they're in. I'm not going to wire it up, guys, not for a prototype. I just want to prove that the mechanical side fits. And here is the first part of Jonathon's throttle. This is the number 1 side. I'm hoping that we'll get the number 2 side in because it's just a mirror of this side. So I only have to create 1 throttle lever and then not reverse engineer it, just mirror it, flip it over. I think it looks quite good, as in, if I show you his old version, it's more to size. The base isn't. The base just happens to be the perfect size to fit on the bamboo bed. So that's why I've kept that size. I have not gone bigger for him, because if anyone else kind of wants to make this from the plans, then they can just push print and go. I've also, the whole idea is I've used Jonathon's basis because it's a non-motorized throttle, and we can make it without all the bearings, without all the hardware, and make it just as simple as possible. Hence the micro switch for the thrust reverser, or you've got the pot as well. But you have got the thrust reverser lock until it goes into the gate. And of course you can't pull it out anywhere else. In fact, you can't move the throttle lever backwards or forwards until it's away. I'll go away now and work on the mechanics. So again, I'm going to create 2 versions. We've got the cheap 10k pots that we'll put in here onto gears that will feed off here. And I'm instantly seeing a problem now that I've just said that. This pot location looks a bit too high. I think it's going to interfere with the thrust reverser cup here. It's supposed to be a big gear that sits there for the pot takeoff. This one will be fine, the lower one, but because we need one for this side, that's definitely going to interfere. So it needs to be moved around a bit more. That's going to go to there. Yeah, so there's plenty of room to do that. In fact, hang on, am I lying? I am lying, because the throttle only goes to that position. I was going to say, I'm surprised I didn't see that in CAD. No, that'll be fine. Well, he says that. Let me go and print it and find out. Guys, that's it for tonight's update. That has taken all day to design and create just that little bit there. I think with a bit of cork in the bottom there, we can really increase the friction. So at the moment it's a bit floppy, but the basis is there. And creating these plates, I'm trying to make it so if something goes wrong, because I know from version 3 that these pots do fail all the time. However, I have a sneaky suspicion they failed because they were the pivot points, whereas they're no longer, all that weight of the throttle lever is no longer acting on the pots. It's just a gear being driven. So that actually might aid in thing. But also the second version, I don't know if I just mentioned this, sorry, I'm miles away, I'm thinking a million things an hour, is that I will use the AS 5600 and see if we can get those fitted in there, because that'll be a nice addition. Super accurate, and simple. I wanted to make sure we got the other side, check how the interference fit of the two throttle handles are, and I finally got round to cutting the cork discs for the friction pads for the throttle levers. I want to see how well the cork works. The reason I haven't been able to cut them is that the laser machine has been so busy creating the dual flaps gauges. Now, because you've got to engrave both parts so they meet together and they hide the light, you probably didn't explain that very well, but they've got chamfers in, and it takes the laser, to cut 50 of them, it takes the laser a day, and there are 2 parts to it. So that's 2 days that machine's been running solid to create 50 decal plates. Poor thing, it's been run ragged. Okay, on to the build. I'm probably going to time lapse this forward bit here. It's just building the second throttle. You don't need to see that because we did that in so much depth here. Let me crack on and do that. So I have forgotten to print the knobs, so that I'll do those now. In fact, they're already going. But in the meantime, we can take off this friction plate and fit our cork in there, and we can see how that's going to affect the unit. So I've got to take all these bolts out because that's not how it's going to be assembled. There should actually be threaded inserts in there so we can tighten this plate down onto it. Now to try and get these on exactly, and I'm hoping if I slice it in half, we can stick one half on at a time, so I can put 2 screws in, put it on. That's going to line it up pretty well, like so, and then peel off the second half. And close it down. There we go. Okay, so there's still no friction there. Actually, that one wasn't even done up. Yeah, that doesn't feel like it was done up. Oh, wow. So this is actually quite impressive. That is really stiff. That's definitely going to work as a friction plate. Let's just see how stiff we can go. Yeah, that's ridiculous. You wouldn't want it that stiff. But it just goes to prove the principle that it works. So those friction plates, wow. It's actually bending the PLA stem. There's that much force in it. That's way too much. Let's get the number 2 throttle on. Can we do that? Because this is a pre-mod throttle. Oh, we can, yeah. So that's what it's going to look like. And it has got about 1mm worth of gap, but that's what I was afraid of. Oh, you probably can't see on camera because I'm not focusing you properly. Right, here we go. And if they're held together really firmly, this plate, let me just change this round. No. Even at this angle, there's about 1mm too much, so they're going to crash. So I'm going to go away now and make some adjustments to the centre frame. More than happy with the friction plate. Going to change the adapter, the way the adapter shaft is built to take away that play. Make the correct size holes for the interface here for the brass inserts. You can see that the meshing of the gears was perfect. However, I did forget that on the pots there's a little tang that locates it in the correct position, so to stop it from turning anyway. That's missing on both those. They need to be added. Need to ensure that these holes here, I can already tell, are not tapered for the thread inserts. That needs to be done. I'm going to change the thickness by 1.5mm, so that's going to be thicker, and we're going to create the adapter shaft to go on this side as well to hold them together. But that should make a really neat looking unit for the throttles to start with. Okay, well that's the theory. Well, that's it for this video. I'm really happy with how the centre plate came out. Both throttles you can see now are complete. It's still the wrong size centre plate. That hasn't been corrected yet. I'll have to go away and adjust that. However, I've got the knobs on now. The upper pot, I'll come a bit closer so you can see on camera. So here we go. So there's the upper pot, and you can see that when the throttle goes, this is the maximum stop here. It's going to butt against there, and the gear is really, it's clear. There's plenty of clearance there. There's still no friction plate on the top here. Still need to create that in the next version, but that's because the plate adjustment needs to be created. I'm going to put this down and I'm going to show you, I mentioned the AS5600 earlier. Some of you may not know what that is. Well, it's good because there's no moving parts, and it's a magnetic hall sensor, and it comes on this little board, and you can get 4 of them for £10, which means there's no parts to wear out. It's absolutely precise, and generally some of the guys on Discord just highly recommend them and rave about them. So we can take the pots out of here and then screw these to the back, put a magnet in the gear, and then we've got our position takeoff. I also appreciate that I put a lot of fusion into this design. Let me know in the comments if that's just too much. I know it makes the episode so much longer, and in my opinion probably makes for a dull video, but I know some of you really do want to know how I create some of my parts, and that was the first time that I've used it for reverse engineering, taking the photo, and it worked exceptionally well. Here, down here on the floor in this box, is what's left of Jonathon's throttle. It has completely been taken apart. Each part has been photographed and placed into fusion. And as you can see, so there is the original centre plate, and there is the new CADed version. Come a bit closer just so you can see. I'm going to go away now and make more. As I say, let me know in the comments if you want to see in the next video the fusion before we actually create the parts. Otherwise, I'll probably just miss that out and put that onto the Patreon videos only. Until next time, guys, which hopefully won't be very long because I really want to get this finished within a week. I'll catch you later. Sim out.